Hello everyone, my name is Alex Ivanov and I want to introduce you project of running cognitive services on IoT platform. We'll use Azure IoT Edge. Let's take a look in the three main type of scenarios. We have a connected application when we run a code on an IoT device like Raspberry Pi, which is connected to cognitive services in Azure and do some analysis and take back the response. And another scenario when we get connected to the Azure Cognitive Services with the same code but running inside of the container. Here we can use IoT Edge, Microsoft IoT Edge platform. We can connect our device to Azure IoT Hub and leverage cognitive services again running in Azure. It's more manageable solution than the first one because it's allowed to manage your device, to update a new version of containers, and to collect some logs of execution without signing on device or connecting by SSH. And the last scenario which I want to demonstrate to you as well, it is disconnected container scenario when we take off all relations to Azure Cognitive Services and run them on a local platform, better on IoT Edge platform to minimize latency of connection. So this scenario is the best because all decisions whatever we need to make about snapshot we're taking from camera, we analyze on the same device or on a local device within a local network. And it will minimize the time of communication and will improve stability of the platform. And of course, this platform will be managed by Azure IoT Hub, so we can update the latest version of images, take a look, and monitor this process on Azure portal. Let's take a look in it. And we'll start with the first application scenario when we get just C# code, which is simply takes images from camera and reads and parses text with a form recognizer cognitive services. Actually, it's taking image from camera of business card. So business card will be analyzed and will parse name and company. And then this code will use speech synthesis on speech cognitive services running in Azure to synthesize name and company of the person who give you business card. So that's kind of helper of pronouncing name because with name pronunciation, name pronunciation is quite a difficult process, and Azure services can help you with that. And also we take a look in communication between IoT device and form recognizer and speech cognitive service. For form recognizer, we will use unmanaged algorithms, unsupervised algorithms, and we'll use just for parsing business card. So business card finally is going to be detected from the snapshot, and name and company is going to be pronounced through the speech cognitive services with the generate audio stream, which will be played on a speaker of connected to IoT device. Let's take a look how this demo works. Okay, it's my project, C# code. Not going to deep dive in the details of the logic because you can find it in my repo and take a look what's going on. I have a code and I have a settings file. In the settings file, I provide information for my cognitive services running in Azure. It is speech service and form recognition service. Provide endpoints and provide the keys for it. Also, I provide a name for my camera application, command line to run camera application and taking snapshots, and the name of the file. So my container will take a snapshot, then it will be picked up by code and sent for analyzing. Pretty straightforward code, so let's make sure it is built. And we can push that code on my Raspberry Pi. But first, let's take a look in the setup. This is my current setup. I have a box with a camera on just to stabilize the camera image, and I have a speaker set on top. This is my Raspberry Pi, and we'll see that is actually connection from speaker. It's just for power because speaker is connected to the audio jack. Also, I have a power jack connected, and I have a camera. This is my camera, which is taking pictures of one of business card. I have several business card for test. So this is my setup, and we can get connected to Raspberry Pi. I'm connected through the local network. And I'm already connected through the SSH. So that is my Raspberry Pi console, and we can run a test. Let's run a test for a speaker first, and have command for it. That is speaker test. Make sure that speaker is connected and provide some sound. Let's take a look. Yeah, that is normal. It means the test is actually works fine. So speaker works, and now we need to take camera picture to make sure that this camera is set up correctly. And I use FS webcam, same application which I will use inside of my container on the next demo. So right now I have just a code which is execute the same command. Let's run the same command to make sure it works. And what else we need? We need WinCP to get the file from my Raspberry Pi. Sounds good. I'm connected. That is file which should be just taken. And just taken. Let's copy it to the local drive and open it from Notepad. I won't say that the best, but it is one of the cards which I want to recognize. Sometimes when I take a snapshot, it's going like that, but just it might be camera glitch, but it should be work. So business card is actually recognized and we can read the name, right? So let's go from there and let's copy. Let's create a folder here. I will name the folder test. And also I need to make sure that I copy my latest files from here. So that's my test folder. And I need just to copy path to my files and copy all my files. I'm not going to copy the bin folder because I'm going to build the application on Raspberry Pi. The application which is built on my laptop is AMD platform, but I need to build with ARM platform. So files are there, and we can on Raspberry Pi, and we can start the build. So let's do cd in that folder and run .NET build to make sure that it's built correctly. It's going to restore packages. Of course, your Raspberry Pi need to be connected to internet. So give him a few minutes to complete the task, and then we can run the application. Yeah, it's downloading packages right now. I'm using a few packages. I'm using package Azure Form Recognizer, Azure packages, of course, and some of the Microsoft packages for speech as well, cognitive services speech as well. And it should be downloaded shortly. Let's make sure. Yeah, that's already built. So we can run. Let's do .NET run. To make sure that everything looks good. So right now my camera should start taking an image. Give him a minute. So image taken. See, it's sent for analyzing.
Sean Whitmore.
And it's pronounced the name. You might be hearing it through the mic. One more time.
Sean Whitmore.
Okay, let's give him another card.
Linda Baker, licensed real estate broker from Hamlet Residence.
Yeah, this one is working much better because this card actually has all required information on. Let's take this image from, let's take this card.
Bob Andre CC Concierge.
Yeah, everything looks good. So seems to be application is working. So we can exit from application, and next demo we'll try to build a container from that application. The next example of connected scenario, we still need to connect to the Azure Cognitive Services, Form Recognizer, and speech cognitive services. We'll use the same code, but this code will run on container. Will run in container on the same Raspberry Pi, which I demonstrated before. And this code will also get access to the camera and mic. I actually provide this permission for containers because by default containers is not able to access to the camera for security reason. But IoT Edge helped me to set up this process. And here we have IoT Hub, which is manage IoT Edge update of the container and also help us to spin the container and pull the logs through. So finally, we have the same code, which is detect business card and parse business card from snapshot and pronounce the name as previous one, but running in container. Okay, let's get started with IoT Hub deployed on my Azure subscription. IoT Hub is actually deployed in a standard mode. I have IoT Edge devices connected to. I already have some communication between them. I will use that IoT device, which I previously registered and set up. All agents and hub and also my container, which I tested previously, working fine. We also can pick up connection string from here to connect IoT Edge on device to my hub. All details you can find on my repo on GitHub. What else? We also need container registry, ACR, Azure Container Registry. It's container registry for keeping images of containers I want to run on IoT Edge. You can find the container with same name. It's a say the name. It's container, which I previously built several versions. So latest version is 3, and I want to build a new version to just demonstrate you how the process works. So I need a new terminal, and I need to make sure that everything's set up. It's the same code like I demonstrated previously. It is located in the modules. In the module says the name. Also, I have a few configs, which is connected me to the latest version. So from my container name, I have 2.3, the latest version, and I want to update that version from my module. and on my module 2.4. Let's use 2.4 version. And I need to make sure that my platform is actually set up to RM, because my Raspberry Pi is running on RM platform. Seems to be all set, so let's Visual Studio to help us to build the solution and push it to the container registry. So let's do that. First time when you build container, it takes a while, but then it's going to be pretty quick. So it uses the same code like I demonstrated previously, and it should be pretty quick. You'll see already everything is pushed, and we have a new image pushed on registry. It's a point 2.4. So now we need to push that image to the IoT device. But first, let's get connected. Same IoT device, the same setup like I demonstrated previously. And here we have IoT Edge list, common to demonstrate me currently running containers. So my container is working on 1.4, which is pretty old version, but we will push the new one. Let's do that. We'll do that through the Visual Studio. Just select the device and choose create a deployment for a single device and provide config file have for RM. Let's use that one. In a few minutes, we'll see that device is actually going to be pushed. We can do the same. We can check the same on our IoT Hub. We need to find our IoT Edge device, and check out the container version. There's my container says the name. So we'll see that 2.4 actually already, so that is version which is reported, and 2.4 already deployed. Container is pretty small, so deploying is taking just a few seconds. Let's make sure that we have a latest version. Yeah, you will see right now 2.4 is the latest version which I just pushed. And we can start testing. I can provide one of the card, and also I can monitor the output from the container name. I need to put the container name.
Sean Whitmore.
Yeah, and you hear that it's actually one of the card is already recognized. So let's wait one more time to make sure. No, it's not taking the image correctly. Let's try something.
Sean Whitmore.
Yeah, it's got it. Let's try another credit card. Oh, business card, of course. And one more time. Business card is not detected. It's taking every 15 seconds, every 5
Linda
seconds.
Baker, licensed real estate broker from Hamlet resident.
Yeah, that's another card is detected. So all set, and we can move next to export the container and run them on a local device. Third is disconnected scenario. So third is disconnected scenario of the same code, which is running in the container as previous, but this code will connect to the local containers with a form recognizer and speech recognition or speech synthesis. Actually, the three containers will be used here. We need to have computer vision because form recognizer need to read symbols. So we'll use computer vision for recognition of text from image. Then we'll use it for parsing with labels and unsupervised algorithm parsing of business card. And then will use speech container to synthesize speech. Unfortunately, those containers can be run only on AMD platform and cannot be exported to Raspberry Pi, which is running on RAM platform. So soon I believe Microsoft will provide support for RAM containers, and we can run them on Raspberry Pi. Right now, we cannot run them on Raspberry Pi because it doesn't support Raspberry Pi platform. But we can run them locally, which is also minimize the latency. I will run it on my laptop, which is connected to Raspberry Pi through the local network, and this connection is going to be fast as well. So we'll run the containers on my laptop, and then we'll run the same code like on previous demo on a Raspberry Pi. So finally, we'll have business card detected from snapshot and name and company of the person pronounced it. And also we'll get billing of those containers reported to Azure. So this is going to be a bill you depend on how often you use containers. And this is billing information need to be periodically sent to Azure. It's not required you online connection, so your device can be on and off, but when it's get on to internet, it's basically send this information back to Azure. Let's take a look. Okay, we return back to our Raspberry Pi. Let's make sure that Raspberry Pi is up and running, and use my previous version of the container. It's version 2.4, which I used for previous demo. So we need to update new version of the container, and we also need to remap our container to use local container instead of using container in Azure. For that reason, I create Docker Compose file where I run 3 containers. One of them is for speech, another one for business card, it's a form recognizer, and the last one is for OCR. It's a visual container of visual services for reading the text. So those 3 containers is required to run because the business card container form recognizer is used OCR algorithms for it. I also provide all billing and API information to make sure that containers start and working correctly. That is billing information need just for billing purpose. It's actually don't use any endpoints. And we can start new terminal and we can start those containers. I'll use command docker compose up, and you'll see the containers is starting. We need to make sure the container works fine, and we need to also reconfigure app settings file. Previously, app settings file point us for containers. Point us for services running in Azure. Right now, they point us for containers running on my local host. I use localhost, so that is my localhost IP address. But of course, localhost for Raspberry Pi is going to be Raspberry Pi. That's why I use my internal IP address. I'll copy and paste that in a new browser to make sure that container works. Looks like container works fine, and we also can check the another container, 502. 502 container also works fine. So just double check that Swagger works as well. So you will see that is actually form recognizer, and this is a 5001. It's a speech container. Looks like all of them is running and ready for use. Okay, let's provide this configuration for new version of container. And my current container version is 2.4. So we need to update them on the module for that version. 2.4, 2.5 is going to be next. I'm going to save that version and start another terminal. From the terminal, I will monitor the updates. And we also again need to generate and build solution and push them in container registry. So it's going to be 2.5. It's going to be built. Give him a few means to complete. Then we can check the registry and make sure that container is actually uploaded. Yeah, it seems to be good. So let's return back in Azure portal, find the container registry, find the repo, and find the container. Is actually say the name. Yeah, 2.5 is the latest one. But on Raspberry Pi, we still have 2.4 instead of 2.5. Just to make sure, still have 2.4. So we need to push a new container. We'll do that from Visual Studio as well. Return back to Visual Studio, click on template and choose, click on device and choose create a deployment for a single device. And we need to provide the config file. Yeah, it should be config file for RM, but my is different. So I have to change it, by the way, or I build it for a different platform. Now works better. Let's repeat the same command again to make sure everything is generated. So push it again, and then choose the deployment mode. So we should be good with config file. Let's select the config file. Just need double check if the config files actually have the containers version we're supposed to have. 2.1. No, actually it's not what we're supposed to have, right? So we need to actually put the version 2.5, right? So should be generated automatically, but something is going wrong, but I can do it manually. One more time. Create a deployment. Choose the config. And we will monitor the updates. 2.1, that's my previous version, and the new version should be comes up. You'll see 2.5. Yeah, we are on the latest version. Okay, let's give him in a card. I can monitor logs. Card is not found yet. Still nothing. Okay, seems to be not good. Let's give him another chance. Okay, still.
Sean Whitmore.
Yeah, now it's detected. And you just heard it. That's error. Sometimes this comes up.
Sean Whitmore.
It is just a problem of access to the audio interface, but it's okay. So as you heard, container works fine, and we use local service. Let's choose another card to make sure that it works as well. And one more time.
Linda Baker, licensed real estate broker from Hamlet Residence.
Yeah, looks like it's working as well. So we're all set. So right now we have Raspberry Pi, which is connected to my local host. It's not going to Azure, and it's used my containers running on a Docker, and it uses those containers for recognition. And the fourth scenario I want to demonstrate you, that is still disconnected container scenario, but this is a fruit detector. Named fruit detector because it's going to detect some objects, which is appears on camera. We have a Python code. Which is running in the container, taking an image, and then calls the local container, which is running on Raspberry Pi with a custom vision. So custom vision allowed you to export the container with compact version and run them on AMD and ARM platform. So we can run them locally on laptop, but better run them on Raspberry Pi to minimize again latency of connection. So here we have a perfect scenario because custom vision container can be easily exported. And we train that container to detect some fruits, which appears on the camera. So let's take a look how the object, fruits, is going to be detected and recognized, and also the billing still sent on Azure about usage of the containers. Let's take a look. So let's take a look first on the schema. So what we have here, I have my Raspberry Pi running IoT device running on Raspberry Pi. I have a Docker containers, few Docker containers running here, and they communicate with each other by HTTP. So I have object detector and camera capture container. Camera capture is capturing images and send for detection to the object detection, and then object detector is upload them to the Azure to store somewhere so we can observe the result. Meanwhile, let's communicate with IoT Hub. We can, for example, send updates on our Raspberry Pi through the IoT Hub and monitor the current state of it. We also use container registry for keeping containers. We also train the model on custom vision so you can observe the result on the custom vision portal. We can export the model. Load in Visual Studio, run build, upload new changes to the Azure Container Registry, and then through the IoT Hub, update our device. So I build everything in one documentation. I also drop the link, and you can observe basically the project and steps you need to set up to maintain. So first of all, we need a Raspberry Pi, external camera, LAN or Wi-Fi access from Raspberry Pi, probably USB keyboard, HDMI cable, and a small HDMI monitor or some monitor which you can connect through the HDMI. I use my 5-inch monitor just to monitor state. Also need a few fruits. I bring today apple and bananas. We'll demonstrate it soon. Of course, laptop with Visual Studio Code and Azure subscription to build some services. You can build free services, by the way, and use the free tier. Let's take a look in my setup and get familiar with Raspberry Pi. So this is my setup right now. I have fruits for detection. I also have my camera, which is pointed to the fruits for detection. And I have a Raspberry Pi. So there's my Raspberry Pi running in the box. So we have HDMI cable connected. We have a small monitor connected through HDMI cable. We also have a camera. This is my camera connected to Raspberry Pi, and Raspberry Pi is running right now and working with the LAN. So it means we are ready and everything is connected and ready for image detection. But of course we need to train the model. Let's take a look quickly on Custom Vision portal. So in Custom Vision portal, I create a project of object detection, and I use some of familiar for you images of orange bananas, and apples, and also grape. So I upload a few of them. I also upload my custom vision for better resolution. I use green bananas. I use kind of ready bananas, and I also use different color of grapes as well. So today I have just apple and bananas. I don't have grapes or oranges to detect. and try to demonstrate you how it works with just a few fruits. And if I have more, I can detect more. So when you upload all images you need, upload your all images, each tag should contain at least 15 images. If you upload more, it's good for you and increase better the result. And then we can switch to to performance. And here we can export the model. So if you click export model, you can see Docker file. And from the list, you can choose Raspberry Pi. Raspberry Pi is working on ARM processor. It's different from Intel, might be running on your laptop. So it's a different type of system, and it's need to be built separately as well. That's why we use Docker for it. The Docker is ideal to build the container and run them on Raspberry Pi. But there is some issues maybe comes up when you're running a container on Raspberry Pi, because if the container need to get access to the camera, this might be prohibited by security settings. So you need somehow work around this problem and allowed to run container with specific permission to get access to the camera. So all the explained details, how to prepare. Yeah, I also have a code in my repo, so you can take a look in the code as well and see how I try to work around this problem. So let's go in further. Let's imagine we already have a container downloaded. We also have IoT Hub built on Azure subscription. It's my Azure subscription, and of course we need to register. IoT Edge device. Each IoT Edge device have own key and can be configured from the portal. So for example, on this IoT Edge device, we can see that agent, hub, camera capture, and object detection is running right now. They are in the running state, there is no errors. And we can manage it from here. We can change, for example, settings. Let's take a look in the object detector. So we have desired values, which we want to set up, and reported values, which we want to set up, which is currently reported by device. So for example, when we do the upgrade of the container and change the version from 26 to, for example, 27 and so on, it is going through desired value and give a command to the device to download it from my Azure container registry, deploy and run. We'll do that experiment very soon, but first we need to get connected to our Raspberry Pi. Raspberry Pi is working on my IP address, so I can reach through the network. It's connected to Wi-Fi. So I need to sign in with my super secret password and I get in. And here I run the command IoT Edge list. List which is giving me the current state of my containers running on my Raspberry Pi. And you can see we're running right now object detector of 26 version, camera capture of the 26 version, and agent and hub that is kind of supported containers help my Raspberry Pi to be updated and managed through the portal, through the IoT portal. So far so good. Let's take a look how my Raspberry Pi is getting access to the stream. So that is video stream running from the camera, and as you can see right now, we have a bananas, we have an apple. I also have extra apple for test soon. So it seems to be video stream is going through, and we can execute analyzing. So the same we can see on inside of Raspberry Pi. For example, if you run command IoT Edge logs camera capture, or yeah, let's use camera capture and put the log from it. Oh, better object detector, right? Because object detector is responsible for detecting objects. And I miss O. Okay. IoT Edge. Sorry for typo. So now we get some logs, that is output logs of the current state. And from here we can, for example, monitor that actually object detector is working right now and actually do some recognition. So the recognition going through the JSON, and this is JSON return back from the object detector with the boundaries. You'll see the widths and heights of the square or rectangle where the object is located, and also probability. So we'll see bananas, we'll see apple detected, and we also have some probabilities here. Some of them is pretty low, some of them better, like 39, 29%, 36%. I won't say that it's the best, but it's acceptable. So let's take a look in the result. So my object detector, when it's complete recognition and analyze respond, it's upload the image to Azure portal. So in Azure portal we can see, for example, in the storage account output images, and we can view this output we got, and also we can see also analyze it output. Let's take a look. So we have analyzed apple and banana. It's pretty small letters, but you can see that apple is analyzed on 37% and banana on 34%. Why is that recognition probability is still low? Because the lights is pretty dark here where I'm recording, and also because the banana which I use not exactly that bananas, which is uploaded in the custom vision, so we can take a look in training images. So this banana is quite different from what I have right now. So to improve probability of recognition, I can take photos from here, upload those photos to my model and train my object again. But let's take another apple. I have another apple and I put my apple here, and I think it's can be taken. So from camera you should see that I put another apple here. Let's take a look soon. It should be updated on a stream. Give him a minute. I try to minimize communication between object, because you know it might overload the free tier if you use free tier by number of requests. So as you see right now, apple is coming. So we can take a look at the result of analyzing and refresh the page. Yeah, and this apple is detected as well, and even with a better probability, we'll see 44% is actually that is apple. And my Raspberry. So finally I have some summary for you. So we take a look in the 4 scenarios. 2 of them is disconnected, and 1 of them completely running on IoT Edge platform. First and second scenario is still use cognitive services and required internet to get connected and communicate for communication purpose with containers. So IoT Edge provides us quite powerful and reliable platform of running containers on IoT device. So we can update those containers when we get a new version, and this is kind of DevOps solution which we set up with container registry and IoT Hub. IoT Hub will help us to configure a new version push new version of containers, and container registry will help us to keep container images. So our Raspberry Pi will get the configuration from IoT Hub, update of configuration, and then go to container registry, pull the container, and spin it, and then we have our code started from that container and works and provides some output for us. What about cognitive services? Of course, we can use them if they run in Azure, and Azure's performance depends on how good your connection. Unfortunately, not all of the IoT devices have a stable connection, and we better run them on local machine or on a local device. But cognitive services is actually supporting free tier, so we can run them for free. In IoT Hub, we also can run for free as well. So you can start your project and play with cognitive services in IoT Hub, even get them to your Raspberry Pi with a free tier of Azure subscription. Most of the cognitive services right now support export in the containers with IMD platform. So we can run them easily on laptops, on servers, locally. And let the Raspberry Pi connected to the local gateway and get connected to those services. Some of the containers support export in RM platform, like custom vision. I previously demonstrated with fruit detector. RM platform allowed you to spin this container on small devices like a Raspberry Pi. So this container will provide you the best performance, because for connection reason, Raspberry Pi make all decision and execute all logic locally on Raspberry Pi without connecting to internet. Moreover, we can disconnect this Raspberry Pi from internet, and it will keep going, because it just need connection to internet for send billing information about how to use containers. So totally, you'll see that's quite easy to set up the different platforms, different code on C# on Python, spin them as a container, manage the containers from IoT Hub and container registry, and use free tier of cognitive services to set up your project. So happy coding!